Yeah, so today's session would entail introduction to machine learning concepts, supervised and then unsupervised learning models evaluation, and then model selection. So over the past week, we've been doing a lot, and we've introduced you guys to the basics and everything that they are supposed to know before building up to the advanced things that they are supposed to do in this particular course. Yeah, so I'll start briefly by giving you some motivation to today's course. Give you a brief history about online, where it started from, and then we actually been in the era of deep learning now. I also introduce everyone has a definition to what machine learning is, and there's a lot of materials around, materials online, and even in our various institutions. So it's actually a broad field, but then the question is, where should I get started from? And that's exactly what I'll be introducing to you today. I'll also continue with that and give you some application of machine learning. Yeah, so let's look at some motivation on machine learning. I just want you to listen carefully to the video I'm about to play now. Sorry, can we hear the audio?
The challenge today is that there are hundreds, if not thousands of
can we hear the audio from the video?
Yes, we could hear.
That's good.
All right, that's great.
now are hundreds, not thousands of artificial intelligence is transforming mission to be able to fuse that much information. Artificial intelligence is transforming the intel community and intelligence in general because the sheer volume of information that can be processed by machines. And Booz Allen is leading and pioneering the use of these technologies today.
Artificial intelligence is able
a team of machine learning algorithms that are trained to help an Intel analyst. They can scale across hundreds or even thousands of screens in parallel and then alert an analyst of where they might need to look at that moment.
Of machine learning today requires a significant amount of information to be fed into algorithms. The challenge is you don't always have that information for the type of algorithm that you want to build.
So one of the key breakthroughs at Booz Allen has been implementing algorithms that generate synthetic data to provide enough examples of images to train an artificial intelligence model.
We've taught a computer to recognize a helicopter without ever having seen a real one. We're also looking across other mission areas like health or natural disaster recovery. There's plenty of implications where artificial intelligence is going to be disruptive and transformative over the next decade.
Artificial intelligence is not about replacing people. It's about providing them the tools to do their job much faster, more efficiently, and smarter.
This is not out in the future. Our clients are using artificial intelligence capabilities that Booz Allen developed today. It positions us to be the trusted partner for those organizations in the future. We're going to continue to see innovations in this area that will fundamentally change the way our clients execute their mission. The opportunity is unparalleled.
Okay. Yeah.
All right, thank you very much, guys, for watching this video. Can you all hear me loud and clear?
Yeah, very.
Yes, we can hear you
Yeah.
very well.
Oh, okay. So the video you actually want is just a motivation on what artificial intelligence, and particularly the evolution of machine learning is doing in our world today. You can see that it's actually in every field these days, from finance to healthcare to academia. Think of it, almost all industries today are utilizing artificial intelligence, especially machine learning, for optimization and, I mean, various aspects of automation. And can you all see the picture that I'm showing right now on the screen? So what can you see from this very picture? You can type your comments on, you can leave your comments on the chat box and I'll read them. I mean, what can you see in this picture? Just type it in the comments, the comment section. Yes, guys, I'm waiting for you. And just I want to say this briefly. And I wasn't able to meet you guys last 2 weeks, because I had a lot on my index. I needed to work on my defense, submit my essay document and all that. So my schedules were very tight last week, so I had to pause and then reschedule certain things. That's why you guys didn't hear from me last week. But then I'm done with everything now, and I'll be working with you guys fully now. Okay. Okay, so someone says cluster of visualization data. So that is from George Osafo. Carl says some clustered data on the screen, from Veronica. Okay. Then Dennis is also saying a kind of scatter plot, maybe. A kind of scatter plot, cluster of data points, some clustering classification of data points. Yes, keep your comments coming. Guys, keep your comments coming. Yes, artificial neural networks. Yes, from Benjani tables point. All right. So if it's attempt to learn everything that we are going to that you'll be one form of analysis visualization in industry. So that is the motivation. That is the whole thing. So if you are serious about the whole program, you are ready to learn everything. You are ready to do your own research, and I mean do all the projects that will be given to you. You'll be one of these guys seated there doing this kind of visualization. And I want to tell you that it is so rewarding if only you will be serious about the program. Now let's look at a brief history, something small about machine learning, where it all started from, and why it is one of the useful tools that we are employing today in our industries, and in fact in various fields of applications. No, in 1764, we can see from here, we can see this very equation that I'm seeing here is called the Bayesian theorem, which started by Bayes in statistics. So this equation was actually a very statistical equation that was used to get information from data. And then they move on to Carnegie. From Carnegie, we went to George Boole. That is from 1764 to the year 1933. So what we are seeing here is simply a transition of machine learning all the way to AlphaGo. AlphaGo is simply an algorithm that was developed recently by some scientists for that will be employed to learn various patterns from data.
ñun ay kaanaas lañu ñun ay kaana lañu man kaana lillaay kaana lawlo
Left.
kaana lillaay.
Okay, let's move on. So in 2012 was actually the evolution of deep learning. And the guy you are seeing here is called Geoffrey Hinton. I really like this guy so much. He came up with the whole idea of deep learning. So he started with just simple machine learning algorithms, and he was doing a research and realized that how about we utilizing an idea on how the brain works, how the brain processes information, and if someone touches you, these networks and all the mechanisms that goes on your body before an action is given. Then he realized that no, we can actually also develop something artificial that will mimic how the brain process information. Then he came up with an algorithm and started working on it until it became possible. So you can read more about Geoffrey Hinton, and the link that I have here, I will share the slide with you after the presentation. And if you want to read more about Geoffrey Hinton, you can just go ahead, click on this link, and then you read more about him and the work that he has done so far in academia. Not only in academia, he has been a consultant to various industries, also in the US, and he's still working in the field of deep learning. So right after the presentation, I'll send this slides to you for you to dive deep into the works that he has done and then extrapolate some knowledge from everything that he has introduced to industry and as well as academia. So what really is machine learning? You've been hearing machine learning ability of machines to learn from data and do some kind of prediction. Some people say it is the ability of machines to learn without being explicitly programmed. Others are saying it is a field of artificial intelligence. Now, before I introduce you to what machine learning is, let's look at some terms: artificial intelligence, machine learning, and then deep learning. And machine learning is simply a subfield of artificial intelligence. So think of artificial intelligence as an umbrella, an umbrella which covers machine learning and then deep learning. So you can think of it this way: deep learning is a subfield of machine learning, and then machine learning is also a subfield of artificial intelligence. So when you think of deep learning, which I introduced to you in the seminar, I think last month, the seminar I heard with you guys last month, we read that deep learning is simply a connection of various neural networks, so many layers that learn from data and then do some kind of generalization. Now, machine learning is simply the ability to perform tasks without being explicit, and it is based on a lot of algorithms. So you train this algorithm to study patterns in data, then learns by itself and do some kind of algorithm. Now, artificial intelligence is based on cognitive function where the machines learns its own ways and then trying to do something on its own without you having some guidance or taking full control of the machine. So just understanding this way, machine learning is simply a field of artificial intelligence, which is broadly defined as the capability of a machine to imitate intelligently human behaviors. Now, ML is used in so many industries. ML is used. There are so many areas where ML can be applied. Can be applied in finance, in academia, industry, in the health industry, and all that. So when it comes to financial analytics, you know, these days there are a lot of data that are being generated by banks and other financial institutions. And in order to gain insights from the data, in order to use the data for some kind of data-driven decision making, you need to employ ML algorithms in order to do some predictions to maximize your profits and how to satisfy your customers. And when you go to security, you've been hearing about cyber attacks, cyber security, hacking, and all that. All these things uh, are sorry, please. As soon as you join, try as much as to mute yourself, okay? So you don't interrupt other people who are listening. Thank you very much. Can someone mute? All right, thank you very much. Yeah, so there are hackers in so many areas, so many institutions where they are working with tools on how to penetrate, hack people's account and all that. And we can also use machine learning algorithm to stop these people, stop cyber attacks, and stop intrusion from people who are utilizing other AI tools to penetrate into people's account. The other area where machine learning is being used these days is personalized recommendation. And I think you guys watch movies a lot. You shop a lot, online shopping and all that. You know, sometimes you buy something online and you realize that something related to what you just purchased just shows up. That is what we call personalized recommendation. So you buy something and then a machine learning algorithm has been built in a way that it gives you something that is related to what you just bought. All these aspects of machine learning that have been employed in industries to meet customer satisfaction. The other area is also called predictive analysis, where you build an ML algorithm to learn from historical data sets. You train it on a huge amount of data set, give it a validation data set to learn from, and then finally you give it a data that it hasn't seen before. Then you check the performance of the algorithm. Right after that, you use a real world data set to check how this machine learning algorithm will be able to make accurate prediction without inferring anything, without human input. The next aspect has to do with product demand, which I've already spoken about. When you go to fraud detection, detecting of frauds, and content generation and moderation. These days, you can simply generate images from text. You can generate images just from anything online. It's called generative adversarial models, which is something fun in the area of machine learning. Think of speech recognition, where you
Sorry, we can't hear you, Prince.
yes, these days speech recognition. These days you can simply speak to your phone.
We,
You tell it something. You can just tell your phone. Can you hear me now?
yes, no, we can
Yeah,
hear.
yeah. Yeah, so you can simply speak something, and then it gives you feedback. Um, uh, there are a lot of AI tools that are utilizing this for various things in industries and all that. You speak to a machine algorithm, you speak to a device, then it starts saying something. It starts doing whatever you tells it to do. All these things are just speech recognition. It's able to recognize your voice and then act on whatever you tell it to do. Self-driving cars that are being utilized in so many countries now, in the US, Canada, Germany. There are a lot of cars coming up with a lot of algorithms and machine learning specifically machine learning algorithm. And these cars are able to move on their own. They are autonomous, and these cars are autonomous because a lot of algorithms have been integrated into their operation, and that is why they are able to work autonomously without any human intervention. Sentiment analysis, where this is where uh, the machine is able to recognize your sentiment, your humor, from words online. So sometimes you log on to a website, and then you realize that a chat bot just pops up, and then it starts giving you start asking you some questions, ready to speak with you and all that. Sentiment analysis, natural language processing is also a field where machine learning is being employed, translating French to English. I mean, language translation and all that. All these things are possible because of the advent of machine learning. Think of Google Maps. You've been able to find your location, Uber cars, utilizing it these days uh, for navigation and all that. Yeah, utilizing it, and not only Uber drivers. There are a lot of uh, institutions who also utilize Google Maps. You go to the airport, airlines, and all this. They all utilize Google Maps for navigation. Forecasting, um, rainfall forecasting, and other form of forecasting, time series analysis, forecasting, and all that. All these are machine learning algorithms that there are a lot of machine learning. You look at them very so random forest decision trees, and even neural network that are being utilized these days for forecasting. Medical diagnosis. also is also one aspect where machine learning is being employed so much. What the only thing you need is the feature, all the features of a particular kinds of disease, how the same things that are associated to a particular kind of disease. You feed all these symptoms to a machine learning algorithm, it learns from it, and then it's been able to predict that with this particular symptom that I've learned from, anytime I see this particular symptom, it means that the patient is suffering from this particular disease, which is extremely powerful. It's utilized in so many health sectors these days for accurate predictions. Yes, automation, banks, particularly in our banks, there are a lot of automation that goes on. Even in our government these days, automating a lot of things without human intervention, which are extremely powerful to reduce human errors and all that. Yeah, so do you have any question? If you have a question, just drop it in the chat and okay, so there are a few questions. If you have a question, you can unmute and then ask.
Hello.
Yeah, I'm listening.
Is there any contribution by? I said that you said for the machine learning there has been some contribution by some individuals. I want to know if there has been contribution by hackers, like trying to bring out viruses. You know, virus try to automate, then do things on their own without any explicit coding or something. I don't know.
Sorry, you mean contribution from who?
Hackers, those who hack systems and those things, like in the market. Was there any contribution from them in terms of this machine learning? You know, they create viruses, and these viruses are able to do things on their own and stuff. So, is there any contribution from them? And what was any, if there is any?
Yeah, so these people are just people who just try to penetrate into the system and then steal information. And the same way they are utilizing cyber security tools and penetration testing tools for stealing information and then entering into systems. Some of them use machine learning algorithms. They just build an AI system that will be working without their input, and then it just start entering into penetrating into people's accounts. The same way they are doing that, an AI or a machine learning algorithm can also be built to counter this effect. In terms of contribution, I don't really know. I don't think whatever they are doing would actually contribute to the positive aspect of AI. What they are doing is negative. There are three aspects of hacking actually. There's the white hat hackers, there's the gray hat hackers, and then there's the black hat hackers. The white hat hackers are simply people who try to prevent cyber attacks and malicious softwares, spams and all that from entering into people's accounts and all that. The gray hat people are just in the middle. They can be good, they can be bad. People who are bad and they always penetrate into systems are the black hat hackers. And these are people that we try to prevent these days using AI tools and building machine learning algorithms. I don't know if your question has been answered.
Okay, all right. So is there any system that is able to do things on its own, which is not employing machine learning? Is there something like that?
Not everything systems that are being able to do things on their own without human input are simply AI tools, artificial intelligence tools. And this, in order for a system to utilize that level of artificial intelligence, means that it has gone through AI, it has gone through machine learning, systems that's gone through deep learning before it's now feasible to be called AI tool. That is why I showed you the picture earlier. That AI is simply a very big umbrella where which is made up of machine learning and then deep learning. So we see this very AI image here. It's a very big umbrella which comprises machine learning and deep learning. And machine learning alone is a very big field. It's a very big field. So many fields: natural language processing, image recognition, segmentations, and a lot of things that goes on in here. And all these things comes together for a system to be before a system can be functional. So yeah, there's no any tool like that, so, unless it is being programmed by a different system. That is, you can simply program a system for it to perform some specific function, like people who do C programming and JavaScript programming. Using those programming language, you can program a system for it to perform some tasks without you giving it any further instructions. And those things are different from what machine learning algorithm and specifically AI, what AI does. Yeah. Machine learning algorithm are strictly based on data set, the data you feed it with. It learns from the data and then it simply starts doing things by itself. We look at that as we proceed. Yeah,
Oh,
I
okay.
hope I've answered your question. Any other question?
Oh, okay. Okay. So I was looking at something like virus and these things, like how it works, able to do this thing. But if it's based on data, then I think I'm okay.
All right, so this person says, is it the same thing that YouTube does to create music mix? Yes, exactly. That's a very good question. So what they do to create your music and all that, this playlist and all these things are based on machine learning. Yes, you are right. And someone says from Fortune, speech recognition, sentiment analysis are all from NLP. Yes, exactly. They are all from NLP. Any other question? If you have a question, just feel free to unmute and then ask. All right. All right. So machine learning was pioneered by this gentleman you see here. He's called Arthur Samuel. He's just an American computer scientist. He pioneered he pioneered machine learning in the year 1950, and then he defined machine learning as the field of study that gives computers the ability to learn without being explicitly being programmed. So what this simply means is that you build the algorithm, you give it a huge amount of data set, and then it learns from these data sets and discover patterns and learns all these features from these data sets. And then that is it, you are done. It can from that it can start doing things by itself without you giving it any further guidance or supervision. That is what it meant by machine learning from uh, ability of computers to learn without being programmed. Yes, and so this simply means that after that, machines can simply recognize images. They can recognize text. We will look at how to classify numbers very soon, or how to classify images, which is called image recognition. You can give an algorithm a lot of data points, and these data points can be cats and dogs, and the algorithm can just loop through all these data set and then group the images of dogs and group the images of cats separately. And you can also give it a huge amount of data set that's made up of just numbers. It goes through or loops through all these numbers and then identify that this is 3, this is 2, this is 4, and so on. And the goal of AI is simply to create computer models that exhibit intelligent behaviors like how humans act, how they process information, how they do recommendations and all that. All these things, the whole idea and the goal is simply to build an intelligent system that is able to mimic the behavior of a human being or do something similar to what a human being can actually do. And a lot more information can be found on this link, the link that I have here called Boris Akat. After that, I'll share the slide with you. You go there and then you can learn more things about more insight and what is suggested on building intelligent system to mimic human behaviors. So functions of a machine learning system, what are the processes that a machine learning system goes through before it becomes successful to we can employ for prediction and all that. So the whole thing is we start with data. That is where it starts from. And data in this sense can be numbers, it can just be text or photos, or like bank transactions, pictures of people, or even bakery items, repair records, time series analysis data. These days, time series analysis, uh, forex, and those things. Those reports, sales reports, and all that. So all these things are simply data points that you can feed a machine learning algorithm with. And once you feed a machine learning algorithm with this data point, the whole thing, the whole process has started. The next is for the algorithm to learn from all these data points and then start doing its own generalization. So the data is gathered and prepared to be used as training. So what we do first of all is to divide your data point into percentages. So you can say you want to use 80% of your data points to train the algorithm. And then after that, you reserve 20% of the data sets, which the algorithm hasn't seen before, to assess the model's performance. And from that 80% of the data set that you use to train the algorithm, there's a percentage that you can also use for validation. So it means that you have three categories of the data sets. You have the training data sets, you have the validation data set, and then one last aspect of the data set is called the test data set. So these are the three main processes of training the algorithm. So you feed the algorithm, and mostly all these data sets are historical data sets. So after that, then it means that if you get a very good accuracy, your model is not overfitting, it's not underfitting, it's just a very good model that can be used for prediction and generalization. then you can employ it on real world data which can start working in time. So that is where you get your YouTube being able to create its own playlist based on videos and musics that you watch on YouTube. And if you are one who normally do online purchases and other things online, realize that most of the things, if you keep ordering certain things that are similar to other things, the algorithm automatically recommend certain things to you. And all these things are based on machine learning algorithm. Now, I want to ask you a question, and I want to see your answers on the chat box. So, because machine learning algorithms are based on data, or they are solely based on data sets, does it mean that the more the data sets, the more the accuracy of the model? If your answer is yes, you give me a reason. If your answer is no, you give me a reason. Yes. If you Okay, so who said no? Someone says no. Manu Isaac says no. If you make this. Yes, keep your comments coming. So I have an ML algorithm. Think of a support vector machine or random forest or maybe a neural network, XGBoost algorithm, any of the algorithm. If you want to, because machine learning algorithm are based on data, does that mean that if I give it a huge amount of data for it to learn from, the higher the data, the higher the performance or the higher the accuracy? Is that true? If it's true, give me just give me a reason if it's false and attach your reason to it. Yes, keep your comments coming. I'll read them out. Okay. Isaac says definitely no. Someone says I can't hear anything. Can you hear me louder? Guys, can you hear me?
Yes, we hear you.
Um, Malama says yes because the sampling error is reduced. Veronica says yes because the model has more information for predictions. Yes, you are right. Isaac comes in again. Isaac says accuracy is not determined by the high volume of data. Okay, we'll look at that very soon. Joel says, I think that's the quality of the data is rather key. All right. Okay, so these are very good comments. Someone says, okay, then he said, true, because more data means more training, and more training means more accuracy. Some amount of data is held, and this amount of data that is being held will finally be fed into the machine learning algorithm, and then it will be able to make its own prediction without any help. And once you do that, it means that if you get a very high accuracy, that is from trusted model which can be used on apply on real world time. Implement it on real world where you'll be generating data set from data set online, and then once the data set is being generated automatically, at the same time you're also using those fresh data set for your analysis and automation and however you refer to it. Yeah, so now the result is now model is a model that can be used in the future with different sets of data sets. So this is where you now use the data, the machine learning algorithm on a real-time data set. So in summary, this processes or this function of a machine learning system can be categorized into three areas. The first one is predictive, second one is descriptive, predictive, and then prescriptive. So descriptive is simply where the system uses the data to explain what happened. So you give, for instance, you give a biological data sets, maybe a data set that is uh, that is made up of features of someone who has diabetes, something like the age of the person, the the blood type, the sugar level, and all that, the weight of the person. All these are features that can be fed into the algorithm. So the algorithm simply goes to loops through all these data sets and then finds out what is happening in this data point. So it simply predicts. Descriptive simply means what happened, what is happening to the patient, or what is this data point made up of, what information does it carry. I think last 3 weeks I introduced you the type of data set that we have, and we said data set simply means information. It carries information, carries specific attributes and different characteristic or something specific. So looping through a data set, the algorithm will try to look out for patterns and find out what is happening. And once it's been able to do that, it moves on to the predictive section where the algorithm uses data to predict what will happen. So what has happened, and down the predictive aspect is what will happen. And then the last aspect is the predictive system, the predictive section where the system will now use the data to make suggestion about what action to take. This is where the recommendations will come in, the sentiment analysis and all that. Doing all those things to satisfy customers and satisfaction. Yeah, so machine learning algorithm can do so many different things. Every algorithm can do so many things, different things, distinct things. So we look at supervised, unsupervised, and then reinforcement learning very soon, where all these sections comes with own algorithms. Some are used for clustering, some are used for regression, some are also used for classification. So I'm leaving this link here. If you want to read more about machine learning, the functions of machine learning, and other processes of machine learning, feel free to click and it will take you to a website where you can read more about it. So let's look at subcategories of machine learning: supervised, unsupervised, and reinforcement learning. So supervised learning simply means you have a huge amount of data set and there's an expert called a data engineer who will label all these data sets and allow the models to learn and grow more accurately over time. So for instance, it can be an image of cat and dog where the cats are labeled, the dogs are also labeled. So the algorithm will simply um, just study the patterns, group all the cats in one section and then the dogs also in one section. Pictures of cats and dogs on its own. So the images that we are seeing here is simply an image. So we feed this image into into the neural network or any algorithm that you are working. It can be a classical machine learning algorithm, and then it's been able to predict what image you are using. So supervised machine learning is the type of machine learning that we have out there, and it's based on labeled data sets. Okay, let me see if there is any question. Um, I don't get you. Te Boho. I don't know if I'm pronouncing your name accurately. Hey, see my screen. All right. So this is not always the case, especially in machine learning perspective. You train the model with all the data and use the very same data to make test or validation. The model will definitely not be able to identify new patterns that were not present in the training set. Yes, this is true. Is this a question or we need a clarification on something? Could you come again, or if you would like to unmute to and ask this question, I'll be very happy to answer them. All
No,
right,
it was not
so
the question. Just
let's
replying.
proceed. Yeah, so supervised learning helps organizations to solve a variety of real-world problems at scale, such as identify spam in separate folders from your inbox, and this has to do with your emails. So there are a lot of fraudsters around who will send you information and all that. And once you click on it, it simply means that they have access to everything, files on your mobile phone, or even if you are using your machines and whatever. It's just a simple text that they normally send. And then once you click on it, it means that they will have access to all the information on your system. And that is very risky. So what's normally happening is that email normally uses this machine learning algorithm to separate spam messages from messages that are real. And what I listed here are simply some examples of machine learning algorithms. You have the neural network, the classical neural network that we have, the ANN artificial neural networks, and then there are other network and all that. Naive-based algorithms, those were different algorithms. Decision forest, one of my favorite algorithms, support for vector machine. And there are a lot more examples of machine learning algorithms out there. And as we produce probably today or tomorrow, I'll introduce you to most of the algorithms out there. Now let's quickly move to unsupervised machine learning algorithm, where you are not working with a labeled data set now. You are now working with data sets that see my screen, not labeled. So different type of data points. So what happens is that the algorithms now look through this and then group the data points according to some patterns. The patterns can be based on similarities or sizes or anything that you have actually programmed it to look out for. So the image you see here, what it just discovered patterns or data grouping without human intervention, and the algorithm simply finds patterns or trends that people aren't looking out for. So for example, the machine learning algorithm program would look out through a collection of fruits, which I have here. I have a collection of apples and banana and all that. So it looks through all this collection of fruits, or it can be anything at all, and then it groups them according to similarities. It realizes that this fruit is the same as this one, this fruit is the same as this, and then it groups them neatly. This is what we call unsupervised machine learning algorithm. These are simply data points without labels. An ability for this type of algorithms to discover similarities and differences in information makes it ideal for exploratory data analysis, like cross-selling strategies, customer segmentations, and image recognition. They are these areas, or the strength of this algorithm makes them ideal and suitable to be employed in these specific areas. The last area that I want to introduce to you is what we call the reinforcement learning, where machines learn train learn through trials and errors. So for instance, if you have a dog in your house, you train the dog that if you do these specific things, you get this reward. So you just try and error and then giving it a reward. So if it does a good thing, you give it a reward. If it does something but you don't give it a reward, you rather punish it. So it's simply a way of reinforcing positive actions and then looking down upon negative action. That is where we get the name reinforcement from. So what you want to do is to simply reinforce positive actions over and over again, whilst you give a negative reward for negative actions. And the sequence of successful outcome would be reinforced to develop best recommendation. So once you keep reinforcing positive action by giving rewards, it means that you are gradually maximizing the potential of the algorithm to generalize well. So the image that you see here is simply an image that depicts how reinforcement machine learning algorithms looks like. So I have an agent labeled as a mouse, and we have different path that it can take to get a reward. So if it takes a path where there's food, it takes it, and definitely there's going to be a path where when it passes, there will be no reward for the agents to take. So that is the whole idea of reinforcement learning. You do something positive, you get a reward. You do something negative, you don't get a reward. So deep, if we have much time to stay, because this is an area that I'm so much interested in. And reinforcement learning can train models to play games. So your self-driving cars, gaming, those of you who like FIFA games, those FIFA games and PlayStations and all those things are based on these areas. A lot of gamings and all that based on this area of reinforcement learning, not only machine learning. Sorry, not only unsupervised learning. So if you want to read more about reinforcement learning, the insightful aspect of it and what you can use it for, you can read more about it on the link that I have here. Yeah, so I've simplified everything here. You have machine learning being categorized into three areas: unsupervised learning, reinforcement learning, and then supervised learning. So if you pick unsupervised learning is made up of two areas. The first area is known as the clustering and then association. So let me first of all talk about supervised learning, made up of two types, that is regression and classification. So regression simply means that when we have a data set that is continuous, that is where you employ regression models such as linear regression, support vector machine regression, and then regression tree to build your model. However, if you have a data set which is discrete, it means that you are dealing with a classification problem. So in this case, you have to employ a classification algorithm such as k-nearest neighbor, decision tree, naive Bayes algorithm, logistic regression, and so on. All right, so there's another type called the unsupervised learning, and this is based on three areas: association, anomaly detection, clustering, and then autoencoders. Autoencoders are special type of algorithms that are used to encode information. We will speak about this as time goes on. And then the last area is learning based, model based, policy based, and then value based. All these are technical terms that I'll explain when we start looking at practicals. Now, what do you want the machine learning system to do for you? And so based on the question that you ask, the questions that you ask or what you are looking out for will depend on the algorithm that you employ. So if you want to see if there are natural clusters or dimensions in the data about different situations, and you could clustering or we'll talk about this thing. If you want to learn what actions to take in different situations, and then if you also want the ML system to be active or passive, then if you want it to be active, you follow the same stream of the flow chart. Then that one will depend on whether you use a reinforcement learning approach or the problem wouldn't depend on machine learning at all. If it is passive, there are several questions to that will arise, whether you want to have access to data that describes a lot of examples of situations or appropriate action for each situation. If your answer is no, it simply means that your whatever you want to do with has nothing to do with machine learning. If your answer is yes, and you want to decide what action to take based on the data you have about the situation, then that will depend on whether to use a supervised learning approach or unsupervised learning approach, which means that you'll be guided on which algorithms to use. So yeah, I'm almost through. So let's look at some useful libraries, Python libraries for machine learning. Let me start first of all with the data, which is the essential thing that you'll be looking at for. So the three categories, that is data mining, data sources, data and pre-processing. Data mining simply refers to the field of data science, which is based on data exploration. So how to get your data, and you can get your data by scraping it online. And one of the tools you can use for scraping data online is Beautiful Soup. I know you guys have heard of Beautiful Soup before. It's simply an algorithm for web scraping. If you want to scrape online in industry, most of the time, if you need a data set to work with, you can't really get it easily just like that. You sometimes have to, because the company has a website, you simply have to build systems that will pipelines and all that to automatically download the data set that you need for various forms of analysis. Another aspect is called Selenium, which is also a tool for web scraping, and the next one is Scrapy. So I'm introducing these tools to you so that in case you get into industry or you want to do any form of practicals, web scraping and all that, you know that there are simple tools for doing that. There are a variety of sources where you can also get data. Uh, one of such sources. Okay, we have Kaggle. Kaggle is simply a website, so you can just go to Kaggle. There are a lot of data sets on Kaggle. If you need health industry data that has to do with health, you go to Kaggle. You get a lot of data. There are a lot of data sets on Kaggle. You can download for your own personal practicals or any form of analysis that you would like to welcome. Someone says the algorithm seems to have fancy name. That's right. Yeah. So guys, if you have any question, feel free to leave them in the chat box. I'll make time to read them as I proceed. So you see your ML repository is simply a machine learning repository where you can also get a lot of data set for all forms of analysis. And alternatively, you can also scrape your data sets online and using these tools for scraping data sets online. You can also use API calls. API calls is kind of a section of data mining where you like to scrape data online. Yeah, Twitter API calls and all that um, for web scraping, data mining, and so on. Data pre-processing. So there are a lot of libraries too for data pre-processing. There's numerical, Python, pandas, and SciPy. All these are libraries that are extremely vital for all forms of data preparation or data pre-processing. When it comes to data visualization, I've listed three different libraries here. Matplotlib, very powerful. Seaborn, very powerful for nice graphics visualizations. Plotly is also very powerful for nice graphics and visualization. So we employ all these things in the practical. So I'll quickly share the notebook with you.
Hello.
SKLN. It contains various classification and regressions. For classification and regression, that is for your unsupervised, for the supervised learning algorithm, and then clustering algorithm for the unsupervised learning algorithm. So all these algorithms are frameworks that are they have their libraries that are being built already in sklearn. So it's in other sense, it simply means that if you want to build, if you want to train uh, your algorithm on some data set that you have, you don't necessarily have to build an algorithm from scratch. A lot of algorithms have been built already and saved in this repository. So you can just import them and use them for several analyses that you like to perform. TensorFlow is one of them. It's also a library that contains various tasks, but generally focus on inferences of deep neural networks. So deep neural network, RNN, CNN, artificial neural networks, and all that. And are embedded in TensorFlow. PyTorch is also very good. I like this library a lot because it contains a lot of resources for uh, computer vision libraries, natural language processing, and all that. It also contains a lot of neural network architectures. Keras is simply a library that was built for evaluating the performance of a deep learning algorithm. So you look at these things as time goes on. Yes, so let me quickly
Hello.
you just have to make a copy and
Hello, Prince.
I just posted a link into the chat box. You just copy the link and paste it in your favorite browser, and then you make a copy of it, and we will get right into the practicals. Yeah, so I'm leaving with some useful links, and some of you have been asking me for books, and for the for analysis that help you make and all that. The book you see here, Python Data Science Handbook, is very good. and there's a free version. The free version is inside the link that I have here. So if you click on this link, it takes you to the free version and you can just download it and then start kickstart. The one you see here, the next book you see here is also hands-on learning with scikit-learn, Keras, and TensorFlow. So you just have to click on the link, and there's a lot of notebook, Jupyter notebook, and codes that comes with this book. So you can download them, and whilst learning, you look at the code, and it will just keep guiding you on what you are supposed to do. If you start learning and you have any question, feel free to inbox me and I'll be ready to answer your questions. Now, the animals on these books are not supposed to scare you. These are simply a way to make sure they get fans on in order to, I don't know, these animals are gradually going through some form of extension, and they want to do something. So it's a way of getting some fans on how to do something about it. So they are not supposed to scare you. So just download these books and then get started with your basic machine learning and data science journey. And there are a lot of books too in the first link that I place here. So if you click on this link, it will take you to a GitHub repository where you can download a lot of books, not only on machine learning, data mining, and statistics, and basic data analytics. So all this, it took me a lot of time to come up with this book. And these two books are personal books that I use myself, and they are very good books. It's not free actually, but I've been able to get a free version. So you just click on this link, it takes you to an online repository where you can just download the free version and start learning. So if you want to also learn more about machine learning, there's a link here. If you want to learn more about deep learning, you choose this link. If you want to learn more about supervised learning, just use this link. And encourage you to also take a look at the 7 steps of machine learning on this link. And also, if you want to read more about how an AI pioneer thinks companies can use machine learning to transform, you just feel free in your own time, just feel free and then utilize this link to your own advantage. Okay. Yeah, so I'm done with the slides. If you have any question, this is the time for you to ask them.
Hello.